Hello everyone, welcome to Urban Subnet. Today we're going to talk about IP addresses. The IP addresses that are used on the internet today, what are they and how are they used? That is the question today for this video that we're going to talk about here. Now, the IP address is a numerical label assigned to every computer device on the network. So that is a number that is assigned to every device on the network. It identifies that particular device on the network that it is on. It is a 32-bit binary number that is divided into 4 octets, and there are 8 bits per octet. So this is a binary number that is used to identify the computers on the network. Now, it can be written in human readable decimal notation, so it is easier for us to understand and see what an IP address is. So the example here, we have 10.10.10.100. That is the decimal format, so we can easily see what this IP address is. IP addresses are entered into the computer device in decimal format also for the very same reasons that it is easier for us to read and write the decimal format, and it also reduces the amount of mistakes that may be made. If we had to enter the IP address in binary, we would probably make a lot more mistakes when trying to enter this information into the computer. So it is entered in decimal format also. Now the CPU reads the address in the binary format. So the CPU reads the zeros and the ones, which is the binary numbering system, has 2 digits, 0 and 1. So the computer would see 10.10.10.100, and this is how it reads the same address that we have here. We use the decimal system, which has 10 digits, 0 through 9, and the computer uses binary system, which has 2 digits, 0 and 1. Now in the binary numbering system, each digit is 1 bit, and each bit has a value. So with this system in place, the values are 128, 64, 32, 16, 8, 4, 2, 1. So each digit is 1 bit and each bit has a value. So let's take a closer look at this. If we look at the last octet here, in this example of this binary IP address, we look at the last octet. 1 means that a bit is on, 0 means that a bit is off. So in this last octet, the last 2 bits are off, so their value is 0. The third bit is on, so his value is 4. The next 2 bits are off, so their value is 0. Then this following bit here, bit number 6, is on, so bit number 6 value is 32. Bit number 7 is on, his value is 64, and the last bit is off, so that value is 0. Now if you add this up, 64, 32 plus 4, that will equal 100. So that's what the computer sees as 100, and we see it up here as 100. But that is how the numbering system works. Each bit in this 8-bit field has a value, and that value is either on or off when adding up. As the computer counts up this string of bits, he sees what the when he gets to the end of the string, he realizes he counted up to 100, and that's what he would put there for that octet. So the binary system is something that sometimes we really have to study just to get a good understanding of how it works. You can practice writing out binary addresses and adding them up, and just to learn it better. It's always better to know how to read and understand the system, so when you're starting to work in this area. And here's an example of an IP address written out in the dotted decimal notation. So this is decimal, dot, decimal, dot, decimal, dot, decimal. This address is 172.16.254.1, In decimal, it's 172.16.254.1 in binary. Now, 1 byte equals 8 bits. So this is a byte. The first 8 bits is a byte. These next 8 bits are a byte, and these are a byte, and these are a byte. So an IP address is 4 bytes long. Bytes is something we might be familiar with because I'm sure we all heard of kilobytes and megabytes. But this is what a byte is. A byte is 8 bits. Now, this IP address has 32 bits in it, and it has 4 bytes. And each byte has 8 bits. And this is what it looks like in decimal, and this is in binary. Now let's look at the value of the binary bits here. So in this octet, in the last octet, the first 7 bits are off because there's 0. The last bit is on, and so that value of that last bit is a 1, and we can see that displayed up here in the 1. In the third octet, the first 7 bits are on, and the last bit is off, and we can see the value of that displayed up here in 254. Because if all the bits were on, then the value would be 255. So that's how we get this value here. Now in the second octet, we have 7 bits that are off, and we have 1 bit that is on. And it's the same thing in the fourth octet. 7 bits are off, 1 bit is on. But the difference is the value of this bit. The value in the second octet is 16 because this bit number 5 is on, and that value is 16. So you see 16 in the IP address. And in the first octet, we can see these 2 bits right here are off. These next 2 bits are on. This bit is off. This next bit is on. Bit number 6 is on. Bit number 7 is off. And then bit number 8 is on. Now if you take the values of these and add them up, you come up with 172 because you got 128, 32, 8, and 4 will equal 172. So this is just a better, I think a better visual display of a decimal IP address and a binary IP address, where you can get a better understanding of the bit values and how the computer can read and determine both numbering systems that we see here. In this slide, we are looking at the display of what you would see when you're looking at the IP address configuration on your computer. So this first side here, this is what we get when we type in ipconfig at the command prompt. And you will see here the IP address of this computer is 128.117.43.28. This is in decimal notation here, dotted decimal notation of this IP address. It has a subnet mask of 255.255.255.0. So we know this is a 24-bit subnet mask. So that would make this last octet, the fourth octet, the numbers in that octet are your host address. So this specific host is host number 28 on the 128.117.43 network. Now we have another host on this network, which is the default gateway. His IP address is 128.117.43.229. So he is number 229 on the 128.117.43 network. Your address, or this computer's address, is number 28 on the same network. Now we have a DHCP server which actually supplied this information to this computer. He is on a different network. He's on the 128.117.8.127 network. Now the reason why we know he's on another network, because we have a /24 network here for the host, this computer, and the default gateway. So the first 24 bits have to be the same. So 128.117.43, 128.117.43 are the same. In this address of the DHCP server, the first 24 bits are not the same, because this is 128.117, but this is .8, not .43. And this is something that you will understand better and learn more of as you continue to study the IP address and IP networking, how to determine easily if a device is on the same network or not. And there's a video about that, about the ANDing and the boolean procedure that is used to determine if a host is on the same network. That is something that's done in the computer software. Okay, and then we have two more addresses here, the 192.52.106.5, 192.52.106.6 are the IP addresses of the DNS server, and as we can see, they are on another network also. So we can see a lot of information on the IP configuration of this computer. Now, we also can see that the DHCP server has leased this address to this computer on June 18th at 1:31 p.m. and it gave it a 24-hour lease that will expire on June the 19th at 1:31 p.m. So that's some more information that we see about this dynamically assigned IP address. Now, from this output, we can get more information too. We see this is a Windows computer. We're looking at the local area connection adapter. So this is their LAN area connection, the LAN, LAN. It's a domain name of ucar.edu. So I would assume this computer is on a educational institution's network, because the domain edu is an education domain. UCAR, I am not familiar with that university. I would assume University of Carolina or maybe, but I'm not sure what it is. But it seems to be an educational company that this computer is attached to. It is a 3-COM NIC, and it's running the 3C905C-TX drivers on this particular NIC card here. The physical address is here, and this is used to communicate on the network also, and that's another video. We have to talk about MAC address assignment, or media address, or physical address. Then we have the DHCP enable, yes, because we know it has a dynamic address. Auto configuration enable, yes, because this address information was auto configured by this computer. Over here we have a network configuration of a static address. So somebody, the IT administrator, network administrator, or someone went into the software on the computer and they came up to the prompt that would allow them to enter in an IP address, as you see here. The first thing you would have to do is make sure you click this radio button, specify an IP address statically, or static, and then you would type in 10.93.127.73. Someone typed that in here, and they typed in 255.255.0.0 for the subnet mask. They typed in 10.93.0.1 for the default gateway. They pressed OK and applied, and they configured this computer with this IP address information that we see here. Now, when you do your IP config from the command prompt on this computer, you're going to get 10.93.127.73 over here, where the IP address will be. You're going to get a subnet mask of 255.255.0.0, which is what was entered in for the subnet mask, and you're going to get a default gateway of 10.93.0.1, because that is what was entered for the default gateway. So the IP config command will give you the IP information, whether it was dynamically configured on the computer or if it was statically configured on the computer. as we see here. So today we talked about IP addresses. We talked about IP address versions. We talked about how IP addresses are entered into the computer. And we talked about how an IP address is used to identify a computer based on a specific host address assigned to that computer, and how the network address is determined based on the subnet mask. If the subnet mask is 24 bits, then the first 24 bits of the network number will be used as the network portion, and the last 8 bits will be used as the host portion, with the assignment of each computer, server, or device on the network. Now, as always, I encourage everyone to continue to use the internet, to use YouTube and the various sites out there to get information about IP addresses, how networks function, TCP/IP, just endless amount of information out there on the internet is available to you. Also, a good thing to do is, since we're talking about IP addresses, go to a Looking Glass website and click around on a Looking Glass website and just do some research and read some of the documents that you find interesting on there. It's going to tell you a lot about who owns IP addresses and how they're being routed and used on the internet itself. And then I would also practice writing and adding the binary addresses, writing IP addresses out in binary. Write them out in the dotted decimal form first, because of course that's what we know. And then down below, draw out your 8 bits per octet, and start writing out the zeros and the ones based on the bit value, so you can add up what the IP address is in decimal. Practice that, because if you're going to be in the IT field, when you're starting to work in IT, or you're trying to get jobs in IT, the questions about IP addresses will come up, and the better that you understand them, the better you'll be able to answer those questions. So I want to thank everyone for viewing. I hope this information was helpful to you, and have a nice day.